Our next property is what we're going to use to help set up some of our next properties coming right after it. X to the 7th divided by x to the 5th. We've got one term and we're dividing it by another term, meaning we have another quotient. Well, let's look at x to the 7th alone. X times x times x times x times x. 7 times. We got 7 of them sitting up there in our numerator. Divided by x to the 5th. Well, we've got 5 of them, x times x times x times x times x, sitting in the denominator. Well, let's pause real quick. Think about a fraction. If I had a fraction, 6 over 10. If I were to reduce this fraction back in the day, by now we're good at, 2 goes into both, divide by 2, divide by 2. But if you remember way back when, before you did that with fractions, teachers would have had you look at prime factorization. 6 factors as 2 times 3. 10, our prime factorization tree, 2 times 5. Well, what happens was when we say divide by 2, fundamentally that came from when I had a 2 common factor and a 2 common factor meant cancel them out, leaving me the 3 over the 5, which was when we said divide by 2 is 3 and divide by 2 is 5. That's where that came from. Canceling out what was in common. Well, when we come back here then, let's cancel out what's in common. Oh, common x, let's cancel it out. Another common x, let's cancel it out. Another common x, let's cancel it out. We got a lot of common x's because it's the same base. Again, this only works because it's the same base. What we're left with is x times x. Now, I do want to show what's left in the denominator. It looks like nothing, but that doesn't mean 0. Just like we mentioned in one of those first videos, there is still that coefficient of 1. I want to think about this as divided by 1 for right now, because being left with that coefficient is going to be something very meaningful to us coming up. Well, look at what we got going on. X times x, x squared. Divided by 1, x squared. Anything divided by 1 is itself. We'll show why that's going to be fun for us later. But let's look at that x squared. Where did that 2 come from? This is going to be when we subtract our exponents. When we have what we're going to call a quotient, a division of 2 powers. If I have a to the m over a to the n, this is when I would subtract a to the m minus n power. Quotient of powers. This one I would subtract. Now I know how much we want to look at canceling out those a's. Those a's don't cancel out like those 2's were. Those 2's, if we want to look at it, were actually coefficients. These a's are bases. Bases do not react the same way that coefficients do. We will be able to cancel later when we have coefficients. But right now, what we're recognizing is when it's the same base is when I subtract the exponents. An example we'll see in the homework, 5 to the 7th over 5 cubed. When we subtract our exponents, 7 minus 3, 5 to the 4th power. And sometimes they will want you to expand it out, but for right now, let's just get used to recognizing when I subtract is when I'm dividing 2 powers.